Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue looking at RMI, Remote Method Identification, and we're going to make a little bit more progress, possibly finish up our chat program. We're also going to talk about the semantics of how things are passed in RMI. So the code that we wrote last time, we'll probably also try to clean this up a little bit by doing things maybe a little bit more intelligently in the Scala type of way. We have our client here. Remember, the first step was to make the remote interface. This needs to be a completely abstract trait where each of the methods says that it can throw a remote exception. Then we need to implement that interface with something that extends a unicast remote object as well as the abstract trait, or the completely abstract trait. All traits are abstract. And we did that for both our server and our client. The server needs to bind itself to an RMI registry, and we decided that the easiest way to get that RMI registry was to call the create registry method in locate registry. In addition, the client needs to look up the server, and then it has the ability to interact with it. Okay, so this is the code that we have right now. First, we'll talk about, so how could we clean this up? Perhaps. Well, it turns out that one of the things that Scala allows us to do very nicely, and this wasn't really an option in Java, or yeah, it isn't really an option in Java. I'm only going to have one implementation of this. So when you run the remote chat, the RMI chat, you're only going to get one implementation of this interface. Same thing goes for the server. And if I'm only going to have one of them, that one might as well be my singleton object down here. So I can do that, and then I can put these methods down into the singleton object. Notice I have no errors, and now I can remove this completely. I'll do the same thing here in the server. Because here as well, I will only have a single server. Though in the server, this does change some of the code. We can't make this because we don't have that anymore. I just deleted it. But I don't need to, because the thing that I want to register is now the current object that I'm in. Okay. So we've changed it so the current object is our implementation of the remote chat server. So I'm just going to bind this to our name, RMI chat server. And this will, this is the reason you couldn't do this in Java, and that this kind of approach wouldn't work, is that your utility classes, they were called, couldn't extend things. But our object can extend things perfectly nicely. And so I'm going to take this approach here. So what happens what do we need to do to make this so that it kind of works? So right now, our login does absolutely nothing. Well, our login needs to keep track of everyone who is logged in. And so I'm going to add into here a val that stores all of my remote chat instances, all of my clients, and I'll go ahead and remember their name as well. I want this so that it can be easily resized as we add people into the program. So I'm going to go up here and do an import of collection.mutable. That way I can very simply make a val that is, let's say, users is a mutable buffer of, well, how about we create a tuple of string and remote chat. Okay. So the string will be their name, the remote chat is obviously the remote instance of them, and so I have the users, and then a login should add those on. So it simply says users plus equals a new tuple of name and client. Is probably going to be one of those, a situation where I'll be better off using the arrow to produce my tuple. Where are we? Type mismatch. Little examples, remote chat, required. Oh, an array of, that's right, this is supposed to return something. If I want to return an array, I can simply say users.toArray as my return value there. Oh, and this needs, oh, and now this is actually, I think I might change my, I'll change it so that we register that and we pass that back to everyone. Of course, now we need to make it so that this matches as well. String comma, remote chat. Okay. The other thing is when someone logs in, we made it so that our client is supposed to be told about the new user. So before we add this user on, I want to run through all the existing users for a tuple of I don't care and the client in users C dot, and here we're making a remote invocation. I'm going to call new users and I'm going to pass them the, actually let's make it so that we're going to change new users here. So it takes both the string and the client, which is a remote chat. And at least for now, I'm not using the remote chat, but maybe we will in just a second. So, comma, client. So when someone new logs in, it runs through everyone who's already logged in and calls for them their new user method. Now this right here is a networked call, and this is the beauty of RMI. This doesn't look like a networked call, but C here is a remote chat object, and so when you call the methods on it, you're actually calling a method sitting off on another computer. After we've sent everyone else the information that this new user is there, we add this user into the buffer and we return an array built from this buffer. For the send message, this was one of the clients said to the server, hey, here's a message from me, and so I simply want to run through again have all of them receive the message of whatever the message was. Okay, and that kind of completes our server. Our client is fairly simple, except we need to have it so that after we have, so our mains don't do anything yet. Actually, for the server, this is fine because the server is now bound to the RMI registry, and we'll check to make sure that this doesn't terminate, but and we can easily prevent it from terminating if we want, or if we need to. Inside of the client, though, we need to do something for this. Actually, let's see, this is our client running. Oh yeah, our server was still running from before. Being attached to the RMI registry keeps it alive. Our client, however, immediately terminated, and so our client needs to kind of enter a loop where we are going to read things and then send it to the server. So while true, I want to do server dot send message of read line. Yeah, simple enough. Over and over and over again, we're going to read a line and we're going to send it to the server. I guess we could do something so that if they type in quit, this terminates, but I'm not going to bother doing that. You know how to write the logic for that. So then we should be able to come over here, start back up our Scala, run a client. This is the RMI chat. Oh, we never logged in. So we have the server, but we're not sending anything to anyone. Server.login. Everyone will be named as Bob right now because I don't feel like writing the GUI code for that. And the client is this. Okay. So now we run this again. And bingo, it sends back to us, hi there. If we run it yet another time, oh, it jumped back to my other one. So I'll write another chat on the console too, and that prints out for number 3. It prints it out for number 3, and we can jump down and look at this one, and it says I'm here as well. So we just wrote a very simple little chat program. The advantage of RMI is that you can add a lot to this very quickly, if you so desire. Now, the details that are worth talking about are when we pass things in and out from these methods. So for example, this method here, we pass in a string, a remote chat, and then we pass back an array of string and remote chat. I'm not doing anything with this right now in the client, but if I was, it would have interesting implications. So when you pass things around to normal methods inside of Scala, you're passing references to them, which is why we have to be careful if they're mutable. It's why the immutable things are a little bit safer. When you're passing things through RMI, the default behavior, well, so what behavior you get depends upon the type. If the thing you are passing is remote, like our remote chat here, this passes a remote reference. So the fact that our server returns these remote references now means that every client knows about the other clients and could actually send messages directly to one another. You could actually have your client, your chat client, completely bypass the server here and send things remotely to the other clients. That's because it's remote. So if the thing you pass is remote, you pass a remote reference to it. If the thing you pass is not remote, then it matters whether or not it is serializable. So you'll remember from the previous chapter on I/O streams, we talked about serialization and object input streams and object output streams. Turns out the string type is serializable. If the type is serializable, you pass it by value. And that is to say that it serializes your local object, it passes a whole copy of it across to the other machine, and the other machine gets a copy. So even if the thing is mutable, for example, this array that we're passing here, if my chat client were to start messing with the array itself is not remote. It's serializable. So I could, on the client side, I could change the array up all I want, and nothing would happen over here. Okay, it wouldn't matter. So if you are remote, you pass a remote reference. If you're serializable, you pass a copy. And it turns out all of your basic built-in types like int and double are all serializable. For our purposes here. If you pass something that is neither remote nor serializable, you get an error. Okay. And in some ways, this should automatically tell you the underlying implementation of RMI is using an object output stream wrapped around a socket so that it can send the serialized objects back and forth. And just like when we were doing that earlier with our networking and with the files, when we ran into problems where things weren't serializable, same thing's going to happen here. If you try to send something and it's not serializable, your program will crash, okay, because it's not able to send it across the network. So you have to make sure that the things you want to send are either remote or they're serializable, because anything else other than those will cause the program to crash on you. So that's it for this video, and we'll come back next time and we'll work on a slightly larger example. And I kind of want to do this example both using RMI and using our standard networking so that you can see the difference. The example that I'll write is a game of Tron. And that will be interesting in some ways because the default implementation of the Tron game uses a buffered image, and that buffered image is not serializable. Okay, so that's something that we'll have to deal with. Anyway, that's it for now, and we'll come back.